So we were founded in 2013. We're actually originally from Paris, but we just opened up in New York, our recent office. So now we're headquartered in New York, and we're growing and hiring. So we definitely invite you to come check out our website. We have some data science positions, roughly we're averaging about one a month right now. So yeah, definitely check us out. And I guess I'll take it to Henri to take it away from here.
Thanks.
Awesome.
All right, thank you. Is it better with the light off? Or
turn it down?
Alright. So, I'm actually going to be doing some demo and stuff like that, so hopefully you guys can hear me without the microphone. I'll try to speak loudly. So, thanks for coming tonight. Thanks for the introductions, and thanks for New York Data Science Academy for hosting us. Today I'm going to talk about a project that I did when I was actually looking for a job as a data scientist, and kind of the approach that I did. So basically, I'm going to walk you guys through some web scraping and some unsupervised learning using a couple different open source tools. Before we get started, just a little bit about me. So my name's Henri Dwyer. I'm a data scientist at Dataiku. Worked on a lot of different kinds of projects there, like churn detection, fraud, recommender systems, and things like that. I'm also an occasional Kaggle competitor. So just to get a sense for the audience, who here has heard of Kaggle? Okay, almost everyone. Nice. And who here has competed in a Kaggle competition? Made at least one submission. Okay, handful of you guys. That's cool. So for those who don't know, Kaggle is a website that has competitions for data science. It's great for practicing picking up the data science. And so originally my background's in physics, and my favorite tools in data science are Python, Scala, and SQL. And as you'll see tonight, I really enjoy natural language processing and deep learning, stuff that we'll be using. All right, so let's get into it. I was asking myself in grad school, I was like, all right, this grad school thing's not working out for me. I think data science sounds cool, but where should I work? I'm sure there's some people in here that are trying to figure out the same thing. And since I was looking for a data scientist position, I figured, all right, might as well, do a data-driven approach to my job hunting. So this is basically my plan. Figure out which companies are offering jobs. So for that, I scraped Indeed. I actually scraped a bunch of job boards, but I'll just be talking about Indeed tonight in the cleaned up project version. And then that school gives you a lot of job descriptions, job salaries, and things like that. But I was interested in finding a cool place to work. So I also wanted to know what employees are saying about the various companies that are offering these jobs. So I scraped Glassdoor, which has a lot of reviews by current and former employees. So are you guys familiar with Indeed.com? Yeah, it's basically a pretty simplistic job board where there's a lot of different kinds of jobs. It's pretty cheap, so a lot of companies put jobs on there. And are you guys familiar with Glassdoor? The nice thing about the Glassdoor reviews is that they have a bunch of different scales that they rank that you can score your company, like work-life balance, compensation, culture, and things like that. So there's a lot of interesting data. And another cool thing is that employees can actually write reviews. So there's all kinds of text in there that we can do some fun analytics on. And so that's the last bullet, is actually seeing what the reviews contain. And so for that, I'll use a technique called topic modeling, which we'll get into in a little while. And as you might have guessed from what I like using, most of the things that I'm doing here are in Python. So we'll be looking at some code tonight. I won't go into too many details, but just to give you a sense for what's going on. So are you guys familiar with Python? Okay, good. You don't need to know too much, but enough to not be scared when I show you data Python. All right, so let's start by looking at Indeed. None of these websites, Indeed, Glassdoor, other job boards, have public APIs. It would be really nice to just call like get all jobs, and then they give you a nice formatted JSON that you can do analytics on. Unfortunately, someone in the audience in the beginning was asking me like, why do you have to scrape? Well, because they don't want to make it easy. I don't know why. I mean, I guess for like, it would be really easy if they just gave access to the data for a competitor to come out and just post all the same job or something like that. Anyway, so there's no easy way to get this data. I mean, you could just go on the website and just manually, do it. But what you can do is a technique called scraping. Yeah, I put searching there because it's scraping's maybe not legal. Anyway, so you use Indeed to search. There's basically two fields: data scientist, New York, NY. Click find jobs. Look at the URL. Indeed is super nice. You're like, okay, there's basically two parameters. There's the Q, which is basically what's in this field, and then L, which is the location. And so doing a little bit of reverse engineering, but nothing too sophisticated. You can figure out, okay, well, if I replace, this with something else, it's going to give me what I want. Of course, there's going to be tons of pages of results. So if you do it, and I wanted to add a couple extra parameters. So going into advanced search, trying to play with a couple of the parameters, you can figure out exactly everything in here to know, like, how do I search for exactly what I want. So a little bit of reverse engineering, understand their API, and then I know how to scrape that. So let me show you what that looks like. So I was asked to do the screen recording, sometimes it stops, so I might have to be starting it up again a few times. All right, so let's go ahead and take a look at code to grab the actual reuse. And by the way, whenever I do scraping, there's a lot of different packages in Python that make it more or less easy to do these things. Maybe some of you are familiar with Beautiful Soup, which does a lot of like parsing of the DOM to give you some nice with a nice API to do that. I actually like sticking with just basic requests, where you just do a GET request and parse the HTML on your own. So what does it look like? Basically, this is my reverse engineered JSON with all the different features, all the different parameters that it takes. I'm using this really cool package, essential whenever you do scraping, called retrying. And what it does is, if there's ever a problem with the network or something like that, it'll just rerun the request. Because there's always going to be some problem. And if you spend like 2 hours scraping and it fails because at one point the Wi-Fi, like you walk in front of your computer, the Wi-Fi didn't work, that's not good. So you add a little bit of robustness in there. And then, so I don't know if you guys are familiar with Xpath. It's basically like CSS selectors on steroids. So basically, like here, I'm finding the next page, the link in the URL. There's like a little link to say next page results over here. So it's a span, has a class, and P for probably next page. So scraping is kind of messy. You have to look at the HTML, figure out what's going on. But there's nothing too fancy that I'm going here. I'm just scraping all the HTML. And one recommendation that I would give you if you ever do something like this, first just grab the HTML and then parse it. You try to do both at the same time. Maybe one page is not going to parse, and you don't want to, again, mess up your scraping. So over here, oh, by the way, I'm doing this in Dataiku. So the flow that we're building is just a series of steps in Dataiku. All right, I'll give that a second to load up. Actually, let's only grab first couple of stuff. All right, so I have my HTML. And just to show you what it looks like, I'm sure you've all seen HTML before. once I have the HTML, I need to then break it out into the useful components. So the key things that we care about are the company that's offering the job, where the job is, job title, because actually Indeed isn't too strict. All right, so this is the HTML that I've gotten from each page. Now from here, the next step is actually parsing that into something useful. So again, my favorite tool, libxml, to do the parsing. And what I want to get from here is just the title of the job, the company, the location, and then the date. Because you don't want a job offer that's stale, or maybe you want to be one of the first to apply or not. So it's good information to know. So here I'm doing a little bit of parsing of all this data. So again, using a lot of Xpath. So for example, the job, it's in this A element called job title. Company is in the span element called company. It's a little bit messy, but you kind of jump in there, just grab the different components one at a time. And at the end, I can get my nice list of jobs. So title, let's take a look at what that is. All right, so here I've got my jobs, my location, and the date. So you can see that they don't give you a nice formatted date. So if I want to do some analysis on the date, I probably need to transform this into something more useful. But you can see over here kinds of stuff. And so if we just take a look at what's going on, you can see some companies have tons of jobs. And the title that comes up, I'm not really sure how Indeed does its filtering, but there's a lot of different kinds of jobs that come up when you search for data scientists. Luckily, the majority is data scientist. But I think this also reflects the fact that data science, there's a lot of different kinds of data scientists, a lot of different roles. So if you're looking for a job as a data scientist, why not get a job as a senior data scientist or data engineer? These are all pretty relevant. At this stage, you could filter out some of the job titles you're not interested in, or just stick with it. For the rest of here, I just kept everything, but I could probably remove some of these, especially some job titles you're not interested in. Okay, that's pretty cool. I have all my companies, the location of where the jobs are. So let me go back to the slides. All right, so there we go. So this is what it looks like, and everything we're looking for is in here, and that's what we're grabbing here. The title, the company, the location. Actually, not every company has the salary, but I think now they're starting to more and more advertise this, so probably I should update it to grab the salary too, because that's always something people care about, of course. Yeah, another thing that could be useful is grabbing, first of all, the reviews from here. I think the quality of the ones on Glassdoor is much better. That's why I mainly did Glassdoor. And then also probably the URL if you want to apply for these. Okay, so now I have, does that make sense for Indeed? That's pretty easy. They have a nice API. You'll see with Glassdoor it's way more fun. So I've got all my companies, and now what I want to do is grab the reviews of all these companies, right? Because we know they're offering jobs. They're probably interesting jobs, so let's try to grab the reviews. And how does that work? So again, try to reverse engineer what's going on with Glassdoor. So there's a couple different strategies here. You could do the reverse engineering that I talked about, or you could just have a script that actually fills in these fields and search and grab the results. It's much faster if you can reverse engineer. So if you go on Glassdoor right now and search for this, you'll get this interesting URL that has at the end like these cryptic letters and stuff over there. So actually, it's not too complicated. It did take me a while to figure out. But basically, the 0 to 13 is the part that it actually searches on. So 0 to 13 comes over here. And then the rest, you can just put whatever you want in there. You can actually end it right here after Dataiku.htm. That'll give you the search results for those companies. So once I know that, I can already grab all the search results for companies, and then you go to the search page and grab the company URL and go see the reviews. Now there's one more trick for Glassdoor. First, figuring out that URL. And number two, Glassdoor actually, if you go there right now, you'll see that it will tell you, oh, you need to log in to unlock all of the reviews. Of course, for my Python script, I can't easily log in. So another little trick, again, don't do this because maybe it's not legal. You can if you search in Google for like Amazon reviews Glassdoor, you'll get to a page where everything is unlocked. And that's because Google has this kind of strict rule with publishers and content that the link to Google can't be something that's, so basically, if Google can index it, then the link to Google should be the same as what the Google bot sees. And so that's why it's often a way to circumvent like paywalls and things like that. Just search for it in Google and then click and you'll go through the article. Same thing's true for Glassdoor. If you on Glassdoor look for like Amazon reviews in New York, you'll see, oh, I need to log in. But if you do it in Google and click on the link, you'll see all the reviews unlocked. So all you have to do when we're scraping this is make Glassdoor think that I'm coming from a Google search, which is also pretty easy. You just modify the header a little bit and grab the cookies from your search, and boom, now your Google search coming to Glassdoor. They show you all the reviews, and then I can do the parsing as usual. So, if you guys want to take a look at what that looks like. My screen recording failed. Just start another one. All right, so what does this look like over here? So let's go back to our little workflow. So if you remember, I grabbed all the companies. In this step, I actually do a little bit of data cleaning in Dataiku. I'm not going to go into too many of the details. But if you remember, the location was kind of messy. Sometimes there were zip codes and things like that, so I got rid of those. And I also created this slightly nicer days since posting column instead of the weird time representation it had. And I normalized the titles and companies in order to make it easier than to search in the Glassdoor. And so how does the Glassdoor code look like? And by the way, all this code is on my GitHub, so if you guys want to check it out, feel free. We have the cookie that you grab from doing it manually in Google, and the end URL of the URL that you used because it's tied to the cookie. And then you just need to put a user agent that matches some browser so that they don't block you. And then with these three things, Glassdoor will think you're coming from Google and you'll be able to grab all the data. And so then, so again, I always use requests in libxml. The only trick here is that for requests, I create this session object that automatically adds the header every time I do it. And then I can just do s.get and grab all the data. So the trick here is first I search for the company, and then I try to click on the right link. Sometimes you search for a company, there's no match, because unfortunately, Indeed and Glassdoor don't share the same database of companies. So some companies are on Indeed aren't on Glassdoor, where the names are slightly different. Even the same company can be multiple names in Indeed. Indeed is pretty bad data. So sometimes you have to just give up no company found. Sometimes you find several, and so in that case, I just picked the first one. Hopefully that's the one that it is. If there's only one, then that's great. You just go to that one. And then here, just grabbing all the different kinds of things, so the reviews and things like that. And yeah, there's nothing complicated after that. So first I grab the HTML. I'll spare you guys looking at the HTML, and then I grab my parsed reviews where I split out everything. So you have the company, the date of the review, and then the different parts to the actual review. So we have employment, like how long have they been working there, their employment status, all the ratings. This is the pretty interesting part. Career opportunities, comp and benefits, culture and values, senior management, work-life balance, the role of the person, and then there were a couple different text buckets. Advice to management. Some of them sound suspicious, like keep doing what you're doing. I bet anonymous employee. I bet he's in the management. And then there's cons. Yeah, this review is really suspicious. Can't come up with any. And pros, great work-life balance. Amazing people. There are actually happy employees. I'm just kidding. But yeah, this data is really interesting. There's lots of stuff in here. But as you can imagine, there's a lot of data. So if I look at how many reviews I got, I have 106,000 reviews. So, I mean, one thing that you could do is just pick a couple companies you're interested in and read them. But the biggest companies have like multiple thousands of reviews too. So that's pretty complicated. So one thing that I want to start with is aggregating by company. And let's just look at kind of the average score for each company. So I mentioned one of the other tools that I like is SQL. Here I'm just using a UI for SQL. And I just calculate the average for each of these different ratings based on, or grouping by the company. So what does that give me? One row per company. So now I'm down to 372 rows. There's a little bit less than there were of distinct companies in Indeed, and that's because some of them didn't match, which is too bad for them. And so here we can see a lot of different companies in here and get a sense for, okay, which one seems like a good place to work. And so let's just kind of explore the distribution of this thing. So what are we looking at? Just the histogram for culture and values. Over here, so most people give 3. I mean, you guys can interpret this. There is actually a skew toward higher values and overall in the different kinds of things, but let's take a look at comp and benefits. This one is slightly more balanced. I guess there's quite a bit of unhappy people with their compensation, and just one more over here. Work-life balance seems to be a little bit more skewed to the right. This is pretty interesting. Gives you a sense for what's in there. And the next thing that we can do is look at for different companies how they compare. So, for example, I think I have a couple examples for you guys. So, actually, yeah, I just put one example to look at, comparing the distribution for 2 different companies to see, okay, which one seems like a better place to work. For culture and values, Comcast, I don't know if anyone works here at Comcast, I just picked them out because they were one of the worst, has a pretty bad, like there's a a lot of ones. I mean, it's basically even across the board. So you have, not the best culture and values, and Intel seems like pretty sweet place for culture and values. Not a lot of ones and twos. All right, so I've spent a lot of time playing with this data because it's really interesting, especially when you're thinking about where to work. If there's any company you're wondering about, feel free to ask me after this. Or just run the code and do it yourself. All right, so that's cool. I did a little bit of analytics on all the scores. I thought that was interesting. I hope you guys did too. But the really cool part in this data is all the text. Because, I mean, numbers, yeah, so this is what the data looks like when I scraped it. It's just one number, right, for each review, but the text has all kinds of things in there. And so in order to make sense for text, there's a bunch of different ways you can try to do that. But what I did was using a technique called topic model. So let's jump into that. A little bit of theory. Who here has heard of topic model? Okay, like about half of you. Who here has used topic modeling? Almost the same amount that have heard of it. That's cool. All right, so there's a couple different strategies to do topic modeling. I'm going to, the approach that I use is something called latent Dirichlet allocation, LDA. The basic idea is this. A document is a mixture of topics. So, for example, this document here, that's an article on genetic necessities, is a mixture of a couple different topics that you can see on the left. And so basically, in LDA, you assume that every document, when you create a document, you just basically choose a bunch of different topics and you mix them together. And then a topic is a distribution over words. So the idea of LDA is, this is totally wrong, but when I'm writing a document, I pick my topics, and then when I write it, first, based on the distribution of the topics, I pick a random topic, and then based on the distribution of words in that topic, I pick a word. And then for the second word, I do the same thing. And you sort of sample from all those distributions, and that gives you a document. So hopefully that's not how you guys write, because that would be pretty weird. But that's the idea in LDA, is that the order of words doesn't matter, and it's more about the distribution of the words among those documents. And so the algorithm tries to, it takes this generative approach and you reverse it to come up with, okay, well, I have a bunch of documents. I want to figure out what are the topics and what are the distributions of word in each topic. So the example here, we can see that this document is, you can see the distributions there. So it's mostly about this yellow topic, a little bit about the pink one, a little bit less about the blue one, and maybe there's a tiny bit of green over there. And then the distribution of the words in these different topics are, well, the main ones are given here. So this one is probably some genetic related topic. This one is about life, neurology, data. And so an interesting thing to note is that these topics don't have names. So I can give them names. Sometimes the name you give is just the most common word in the topic. But inherently, LDA just gives you distribution over topics, and topics are just distribution of words. But we'll see there's cool ways to visualize these topics to sort of understand what's going on. All right, so did you have a question? I can take your question.
Yeah, I was just wondering, did the topics and an expert comes up with that?
No. No, so the algorithm actually infers the topics from all the corpus.
Okay.
Yeah. So the algorithm infers two things. It infers the topics and it infers the distribution of words among each topic and the topics. And there's a couple of different algorithms, LDA, you need to tell it as input the number of topics. I used an extension of LDA. It's called hierarchical Dirichlet processes that infers the number of topics along with the topics. So I didn't have to deal with that because I don't know how many topics there are. But yeah. So this is basically, if you understand how a document's generated in LDA, you can sort of understand what's going on. For each document, you have a topic distribution, and then for each topic, you have a word distribution. And all right, let's take a look a little bit more concrete at a topic, just so you get a sense for what it actually means to have a topic. So there's a couple different dimensions. This is a three-dimensional word cloud. So the first one is the size of the word. Usually word clouds are bad, but here I kind of like it because you can represent all three dimensions. The size of the word is how important is that word in that topic. So for example, this topic, warehouse is pretty big, breaks is pretty big, so those are going to be the main words in that topic. Break. This one is more about balance in life. Flexible. Anyway, so the size of the word is how, if you remember over here, so like this topic would have gene really big compared to DNA, compared to genetic, and the other one, all the other words would be really small. And then the balance from yellow to red represents how unique is this word in the data set. So for example, you can imagine pay is not going to be very unique among all the reviews. Everyone likes to talk about pay, especially when they're reviewing a company. So that's why it's kind of translucent. So the opacity is pretty small. Like over here, short is also really small, so these words are not very unique. And then the last, so the color is how unique it is in there, and then the opacity is how unique it is in the dataset. Definitely should repeat that because I got mixed up myself when I was saying it. So the size of the word represents how important this word is in the topic. The color is how unique it is in the topic, so how unique it is compared to other words. And finally, the opacity is how unique it is compared to the whole data set. 3 dimensions, one chart, pretty cool. So how do we actually implement this? There are a couple ways to do it. Actually, since, so have you guys heard of scikit-learn? Scikit-learn is a really cool package in Python that has all kinds of machine learning algorithms, and they added LDA, I think one version ago, like 0.18. So I'm sure that implementation is pretty cool. GenSim is a package that's mainly focused on doing natural language processing and this kind of work. And they also have an LDA implementation. And there's Blay, which is one of the researchers that wrote a paper on LDA. Actually, this diagram over here is borrowed from one of his papers. He published a C implementation that does LDA as well. So, as you might have guessed, I like choosing the hard way, so I use the C implementation here. But they're all based mostly on the same algorithm, so you can use them. So let's take a look at how that works in practice, and then we'll take a look at the results. Okay, so if you remember, we're about halfway in my workflow. I have all my documents here. And so the first question I need to answer is, what do I consider a document? I could consider it to be each of these individual blocks, actually. So that would give me like roughly 3 per review. Actually, what I ended up doing is just concatenating all of the different text blocks in a review into one document. Makes them a little longer. You can try both. Because some of these are really short. Like, I'm not sure if this would help, or it might add more noise in the data set and you wouldn't find some interesting topics. So a document is all of the text that somebody wrote in the review. So the first step is turning this text into a representation that I can then feed into the algorithm. And so what that means is creating a vocabulary. So basically, most NLP packages, they want you to replace all these words with just indexes in a dictionary. So you just replace them with numbers, then you have a dictionary to refer back to. So that makes it a little bit faster to do all the manipulations that they need to do. And before doing that, you can do a little bit of processing to remove like stop words. So for example, you could remove pro, con, pros, cons, because those are really common. Maybe they don't contribute if every review has them. I also removed stop words, so just words that have no meaning but are very common in the English language, but they don't contribute to the topic. So things like the, something like that. There's some standard lists out there that you can grab. So I filtered all of these out of my reviews. And then I created a dictionary that has all these words, and I wrote out the data into a text file that I'll be able to use to feed to LD. So here I'm using GenSim to create the dictionary corpus and feeding it into my pre-processed text data. And so it creates a dictionary and all of that stuff. A couple other things that you can do here are remove words that are, very frequent in the data set. So you can just set a limit, say if a word is in more than, let's say, 25% of the reviews, it's probably not going to help my topic modeling, so I can remove it frequently. Another thing that I did was remove words that were too rare, because these are probably typos or just someone bashing on their keyboard. There's some weird words in there. And so what I did is, if a word appeared fewer than 20 times, then don't leave it in. And one last thing that I did was filter out documents that were too short. If there's less than 10 words. These are kind of arbitrary. I actually played around with a couple different settings to see what would give me nice topics. It's kind of an exact science topic modeling, so you can sort of try things until you get topics that you're happy about. And what this gives me is some awesome topics. So let's take a look at what it looks like. So these are the documents. I don't know, can you guys see that? Basically, it's my transformed document. So I have the document ID, and then like the number in the dictionary, and how many times it appears in the document. Because remember, we don't care about order or anything like that in this topic LDA world. So like the word 4458 appears 2 times in this document number 48. Pretty interesting. So I have my data in the right format, and I can. So you can do this directly from GenSim. You call it fit LDA. The C version of David Bly was faster in my tests, so that's why I ended up using that, because I have a lot of documents. So basically, you just call this HTTP binary that you compiled and give it the training data, and then give it the output, and that's going to fit the topics. So what does this look like over here? It's a lot of different things, but for example, are there any that I can read? Yeah, it's going to tell me, how many different documents have each topic and things like that. So all the data is output in here, and what I want to do is actually parse this data. So I'll skip the form and switch over to the interpreted data. So now, what I have, almost there, is for each company, the list of main topics. I picked the top 10 here. Really what you can do is, so for each review, you know what the topics are. You can just sum all the reviews for a specific company, and you'll get a distribution over the topics based on that. Does that make sense? So you can sort of roll up at the company level and get that. This isn't too interesting because we don't know what topic 28 is, but we will pretty soon. So I have my topics, and my topic top words. So topics are distribution over words, so we can look at what are the most common words in each topic in order. So this first topic, the words are work, people, job, hi, also. Like here, if we hadn't removed the stop words, we'd probably have some even less interesting words than also, but you know, maybe it has a meaning. So some of these topics are kind of interesting, like opportunities, career, experience, things like that. All right, so this is kind of cool. We have the topics. You can kind of look at this list and see what are people talking about in all these reviews. What I care about, though, is by company, what are the top topics, visualizing that. So I think I do not have my dashboard. Yeah, so I built a little D3 web app. Actually, before I show it to you, I'll talk a little bit about it. So, are you guys familiar with D3? It's almost unanimous. That's cool. D3 is a visualization library where you can build cool web apps like, I think, like this one. And the core of it is basically a couple different components. You have HTML that has the layout of what you're doing. In this case, I just have an input over here where I can filter by company. And then there's the CSS and JavaScript. And so if you're interested in doing these, again, I'll share all the code with you guys. Basically, there's a function that you can call. You give it the word clouds distribution, and it'll create the visualization. And all right, so let's take a look at the web app. I just want to put it up on the full screen. All right, well, this is going to work. Okay, so in here, now you can filter by company and actually look at what are the topics. So the first thing here that I'm showing is just the main topics overall. Just to get a sense. It's the same list as we saw before, but ordered slightly differently. And so a lot of people seem to talk about work-life balance. That makes sense. It looks like it's more positive, because it could be like, oh, the work balance sucks. But the other words in here are like good, okay, great, flexibility. All right, so this is probably not too bad. This one is a little bit harder to interpret, like manager. I don't know. That makes me feel anxious when I see manager in a topic, but told reason is probably not too good. This one's pretty easy to understand, like productive, fast, fun, friendly. This is probably fast-paced. That's cool. Opportunities, career. Okay, so there's some positive things in here. If we scroll down a little bit lower.
And Henri, is each little group a topic?
Yeah. Oh, sorry. So yeah, each sort of group of words is a topic. Do you guys need me to remind you how to interpret the different?
Go for it.
I'll do it again. All right. It's confusing. So, all right. So each of these is a topic. So remember, a topic is a distribution over words, and so that means one way to visualize it, instead of just the list that we had. Shouldn't have done that. Why are you full screen? Instead of the list that we had over here, where it's just the list with the frequency of the word in that topic, you can put it in a word cloud and just have bigger means higher frequency, and it's proportional to how frequent it is in that topic. So here, the size is how big it is. The color from yellow to red is how unique that word is. And so how unique that word is in that topic, so in the documents that have this topic. And then the opacity is how unique the word is overall in all documents. Alright, so I just want to show you some other topics. Yep.
Is it uniqueness in the topic or uniqueness against all of the other topics?
Yeah, so one of them is just the opacity is how unique is that word, just its overall frequency. And the other one is in that topic. Yes. So like job is going to be very opaque because it's super frequent when you're doing a job review. And all right, so we can look at a couple companies, but like this one, overtime weekend. I'm not sure what that is, but I'm not sure I want to work there. Okay, so so here we're looking at overall, but I mean, obviously what's interesting is looking at a specific company. I don't want to offend anyone, so.
We can't see what that is.
So what's pretty cool or interesting is that Amazon is like its own topic because they just have so many reviews. So you have a topic that's just about Amazon, Jeff Bezos, frugal, pager. Okay, so I'm not sure these guys are the happiest people. And what was interesting about Amazon too that I didn't think about, there's a lot of reviews in here that are not from like the engineers and tech, but it seems to be like working in warehouses, boxes, shipping, machines, lunch break, stuff like that. They have this overtime topic in here. From what I've heard of my friends at Amazon, I'm not too surprised. But they also have this like engineering, perks, food, software, coffee. So what I'm seeing is like maybe there's two worlds at Amazon. There's like